Hello and welcome everyone. We are going into kind of a new section, another part of the engineering design process. So this is in kind of your brainstorming or design and prototyping. Kind of depends on what's going on with everything else as to where this element would come in, but the sketching and technical drawing or design. So and you can see by this definition, what I just said, at various intervals in the engineering design process. So you may see it in brainstorming, you may see it in prototyping and areas such as that. The conceptual, mathematical, and physical models are used to evaluate the design solution. So sometimes you can test things mathematically or computationally using maybe even computers or something like that. Sometimes you actually have to build a physical model and test that out to see how things go. So overall, what we're looking at here is we are blending the two-dimensional and three-dimensional worlds, 2D being the paper world, and then the 3D being the real world. So you look at design through concepts, physical and mathematical conceptual, physical, and mathematical representations. Use prototypes and models to ensure quality, efficiency, and the productivity of in your final product, and visualize three-dimensional objects. So that's what we are. That is what we are working with here. And so, just as an extension, these are just various different elements. First thing I want to do before I get into any of the text is just take a look at this picture, and you'll notice while there is definitely some specific attributes that are being incorporated here, at this moment we're still in sketch mode, not so much blueprint mode. So we don't have to be 100% accurate, but we need to be accurate enough to convey the ideas. This is most often done on grid paper or isometric paper. Not typically going to be your standard, just either regular or college ruled notebook paper. Annotated sketches are sketches that include notes or labels, dimensions, and or symbols. So we are bringing in dimensions such as length, symbols. There's symbols for how you draw a door, or in the case of like electrical circuits, you have resistors and capacitors, and they all have their own special symbols that you use. Sketches are often used to show an idea or visually capture a thought. So in most of what we're going to be doing, we're going to be working with an object, and so the sketch needs to represent the object, but also what the object does. So if something should move, there should be something in the sketch that indicates that there is either movement or there is the potential for movements. And all sketches should include some type of annotation, meaning dimensions, short descriptions, different things that are going to go into making up this particular product. Sketching takes practice, but there are some basics to remember. When we are working with our sketches, if you remember my example of a sketch, when talking about an airplane, I drew a box with a plane. We need to get more specific than that, but at this level, we still have a lot of wiggle room. But some key points: use long, light, and flowing lines rather than heavy, short lines. One of the reasons that you want to do something like that is because it's a sketch, you're going to erase a lot. And so if you use a very heavy line, it's not going to erase fully. Sketches are a loose representation of ideas, so accuracy is not critical. I've already made that point. Keep your sketches quick. Include enough detail to get the idea across. Again, this is not a blueprint that somebody is going to follow to build what you are working on. Instead, this is just something that you're using to present to somebody, or possibly even just as your own personal item. That way you can have a basic idea of what you're trying to do. Use basic shapes to frame the sketch, then add in more detail. So if you are drawing something that is mostly rectangular in shape, start off with a rectangle and then you fill in detail and then erase where it is needed. Technical drawing is a visual communication language that is used to communicate how something works or is constructed. Key word, it is a language. It is a language, which means there are rules that you need to follow. We may run into some things that don't make sense and we want to go about them in a different way, but we need to stay consistent because the people that are building are not necessarily the people who are designing. So there needs to be a universal format that everybody follows. So all technical drawing should include standard symbols and units of measurements. So a capacitor, the symbol that is for a capacitor in an electrical circuit, is the same whether you're working in the United States or working in Britain or working in China. To my knowledge, for the most part, it's the same no matter where you go. There is an international set of standards, international units. If you are for your various calculations and everything, you want to make sure that your units are present, because if you're talking about building a skyscraper, the difference between meters and yards is going to make tremendous impact on the structure, especially in its stability, if it's anything over, well, I mean, really anything, because I mean, even a 1 yard versus 1 meter is going to be different enough that it could cause significant problems in the future. Technical drawings can be produced using paper and pencil, which we're going to do a little bit of, but then also on a computer using a computer-aided design or a CAD system. You've heard me toss that term around a little bit. I've used SolidWorks predominantly, but there are some other CAD systems that can be used. So while the paper and pencil drawings have they're kind of going away, they're still very relevant, especially when you're talking about your initial sketches. We'll be using 2 types of technical drawings: orthographic projection and isometric projection. An orthographic projection is a way to represent a 3-dimensional object in 2 dimensions. And so what we're doing with the orthographic projection is we're taking that 3D object, which, you know, you can sketch things out in 3D, but we're moving it into just a flat 2D surface. So typically 2 or more elevations or pictures are produced to represent the entire object, known as multi-view projection. And so what you are looking at when you're dealing with these is you are looking at, and typically they flow this way. You have the top. Underneath the top, you're going to have the front, and to the right of the front, you're going to have the right side. So you have top, right, front, and right. And if you can see from the screen, the dimensions actually have to line up. And so the top of the very top of the right view is level or equal with the top of the front view. The bottom are also level. The right side of the front view is in line with the right side of the top view, and the left side of the top view is in line with the right view. So they actually have to match up. If they don't match up, then, you know, that's something that you have to take into consideration as to, is it an error or is there something going on with the design where they don't match up. Orthographic projection typically displays the top, the front, and the right side views of a 3-dimensional object. For all of you lefties out there, it's the right side, and that's what we do. And I've already explained this fairly quickly, but you can see it a little bit better in this image and how everything lines up. The orthographic multi-view projection has some basic terminology: top elevation, front elevation, side elevation. The construction lines, they're going to be light, and that's what tells us everything lines up properly. Hidden lines, if there's an object with a hidden line, that's going to be dashed. So if there is something going on, like in kind of jumping a little bit ahead here, like in this shape, if this is the front of this shape, when I turn and look at it on the right, I'm not going to be able to see this hole, nor am I going to be able to see this gap. But by the dashed lines, I can tell their locations. Same thing here. I'm not going to see this gap and this circular hole from the top, but the dashed lines tell me that they're there. It takes a while to be able to look at these and kind of get used to what the image represents. But with a little practice, you'll be able to view these objects fairly well. The dimensions are these lines that come out from the side. You draw straight lines, straight and parallel lines, and then you draw a double arrow in between, and then that number represents the distance in between. You can have it singular, or you can have the dimensions stacked as needed. It all depends on your drawing. Drawing orthographically will take practice, but there are some basics to remember. So I just said they're going to take practice. Use construction lines to frame out the workspace. What I do typically when I work with these is after I usually start with the front, then I draw the major features. I draw the lines so that way all of the units are preserved. The height, the width, and depending on how you want to define this one, I would call this height and width is preserved. And then as I start adding in these other elements, the other dimensions, so either you may say length or you may say depth is preserved. Distance between the elevations are equal. So that's where these construction lines are going to be beneficial, is to make sure that everything maintains its same scale. Use construction lines to project details between the elevations. So like also right here, there's an additional element because this isn't a square, it's kind of an L shape, and so this corner needs to be denoted somehow, and that construction line helps us remember to put in that particular feature. Drawing orthographically will take practice, but there are some basics to remember. Okay, same thing. I forgot that it was the same thing each time. A 45-degree angle line can be drawn to help project between the top and side elevation. That's this line. That's this line right here. It just kind of helps mentally keep us in tow with a three-dimensional object. If you were to try and partially fold a piece of paper on that line, you can see kind of how the 3D element works. I never did it in my drawings, but that is something that I've seen a lot in technical drawings. So when you kind of finish with everything, let's go back up to this initial drawing right here. You see everything is still pretty light. But once you are done and you're pretty sure that everything works the way that you want it to, then you go back in and darken your lines. And that tells you what part you're dealing with. Don't erase the construction lines because they're there and helping you construct the object, but also they're there to help others see what's going on. But when drawing those construction lines, make sure that they're light, because otherwise, if you draw those lines really heavy, it's hard to determine what is your part and what is your construction line. The isometric projection is it's a simple way to show a three-dimensional object. If I remember right, it's 60 degrees at any vertex. It's 60 degrees on paper. No, well, sorry, 120 degrees on paper. And even though, like, this is a cube, this is technically a right angle and a right angle and a right angle. But in 3D and in three-dimensional space, these are three right angles. But on a flat piece of paper, it's 120. Isometric, meaning they're all the same. So 360 divided by 3 is going to be 120. That's where that number comes from. By using isometric projection, three sides of an object are shown proportionally. So if this line here was twice as long as any of the other lines, then you would know that the shape was twice as long in this particular direction. But since they are all equal, then I know that this object is all equal. All vertical lines are drawn vertically. So anything that's a vertical line, you just draw it straight up and down, you're okay. And then any of the horizontal lines are drawn in some way representative of 30 degrees or 30-degree increments. So even though this is a flat line in real life, it's 30 degrees relative to what we would actually call line 0 degrees. Drawing isometrically will also take practice, but there are some basics to remember. Use construction lines to frame out your workspace. Using proportions is going to help a lot in this. Use construction lines to project details onto surfaces, and then use accurate measurements on all surfaces. One of the big things to remember here is to try and use accurate measurements as much as possible. So let's assume for this object here, that two of these triangles, well, it's really one triangle unit. If you look here, there's 1, 2, 3, 4. And so let's say that this is 4 inches. And I need to know what this particular slant is, but I know that the bottom is 1, 2, 3, 4, 5, 6, 7. I can draw the vertical line. This is 3 units tall, and from that then I can just connect this line, because this line has kind of a different slope to it. So you have to you kind of have to think through these a little bit. And again, it's going to come with practice, and but it is something that once you get the hang of it, I find it actually kind of fun to do, but it takes a little bit of practice. So what we're going to do initially is we're going to start off with a common household object. You get to pick a common household object. Give it a little bit of depth to it. You can't just say, okay, I found a block, or I found a ball. Give it something that's got a little bit of shape, and then try to draw the object orthographically, and then we're going to submit those, and then we're going to let the class see if they can determine what the shape is based off of your orthographic projections. And so that's one of the assignments that you're going to be working on. I hope you enjoyed this presentation. If you have any questions for me, as always, feel free to ask. You shoot me an email, pop it up into the chat when we come back together, or whatever you need to do in order to ask your questions. Thank you for watching, and have a wonderful day.